Hi, my name's William. Today we'll be going over the ignition system and troubleshooting. Okay, now we're going to explain coil and plug operation and how they work. On this diagram we have a 2-wire and a 3-wire coil on plug, and we'll go over the operation of them at this time. Both of these coil systems operate on the principle of Faraday's law of induction. All right, I'll go over the 2-wire system first, show the power and grounds and how it operates. On the left side here I have the power side highlighted. We have a ground side. We have a transistor. Here we have our load, which would be the coil. Now the basic operating system on this, as the power comes into the coil, you'll have a primary winding, which is larger but less windings. That would be the load in the system. You have the secondary coil, which would be a smaller wire but more windings. The transistor basically operates the system. When it closes the system and provides the ground, the system will release the high voltage. The primary side operates on available voltage, and the high side is the voltage that will actually go to the coil when given the signal. In the 2-wire system, there's only one transistor right here. Okay, the 3-wire system on the basics operates the same way. The only difference is you have a 3rd wire here, a signal wire, and you also have an extra transducer down at the actual coil. There are basically 2 types of coil. You got an NPN and a PNP. The difference being is which way the base of the transistor is pointed. Which is whether it's pointed towards power or ground. The 2-wire system was a PNP, and the 3-wire system was an NPN. Now I want to go over and basically explain Faraday's law, which Faraday's law states that relative movement between a conductor and a magnetic field allows for 4 ways by which voltage can be induced in a conductor: as an alternator, as in a generator, the value of the voltage from the 4 ways of voltage induction depends on the density, strength of the magnetic field, and number of turns of the windings in the coil. So that's basically how it operates. All right, now we'll be showing how to set the spark plug gap using a spark plug tool. A lot of times nowadays when you buy a new plug, they already come pre-gapped, but we'll show you how to check them or set them. Utilize the spark plug gap tool to check or set the spark. I'm gonna go with the 0.40, and it looks like that would be the proper one. It fits between there, there's no play, so it would be 0.040. All right, now we're going to go over some terms to do with spark plug. First one will be the thread size. The thread size is basically the diameter of the threads on the spark plug. Now today, most light duty vehicles, they use a 14 or an 18 millimeter. The next thing we'll talk about on the plug is the reach. The reach is the distance that the plug will screw into the chamber. Heat range, next one's a heat range. Heat range is how well the spark plug disperses heat during operation, and that is determined by how far the ceramic goes and how much ceramic is filled in the bottom of the plug. You have a center electrode, which is this point right here. It's called your center electrode. This part down here is your ground electrode. Okay. Thank you. Thank you. Now let me see what else.
Make sure you just start like just press and let it get.
Go.
All right, this part of the plug is called your terminal. We have this ceramic material here that is the insulator. These dimples here are called corrugation. We have the hexagon, which is where the socket would go on to screw it in and unscrew it. This one has an actual gasket right here. And then there's a metal shell under here. That's it. All right, here we have a wiring diagram for a Chevy HHR, and we're going to go over how the injectors get power, ground, and so forth. We'll just do one injector to explain it. You have our power, which is highlighted in pink, and goes back over to the underhood fuse block. You have an initial module fuse, 10 amp fuse. We have our ground wire to each of them, which I've highlighted in green, and it goes and grounds to the engine block. We have an orange off of each injector, comes off, and that's our low reference wire, which all of them have that wire in common. And then we have the black, which the black in the center smart wire is the one that actually plugs into each injector. So each injector operates with those wires. To check for power on the injector, you could back probe the pink wire at each injector and make sure each of them is getting power. Another test you could also do is you could unplug and plug a Noid into the injector connection, and if it's flashing, then you're getting a signal, power, and everything needed to operate that injector from the PCM. All right, now we're gonna check the power to the coil. We've back probed the power lead into the coil. We have hooked our negative up to our ground at the ground point on the vehicle, and we're getting 12.86 volts power. That is slightly high, but right now this vehicle is on the charger. Key on, engine off. Now we're going to do the ground on the coil. We've backed pinned our ground wire, and once again we've clicked our negative up to the ground. We are getting right now 11.3 ohms, so we're getting continuity, so our ground circuit appears to be good at this time. All right, this time we're going to hook up this spark plug tester and test our spark at the coil. All right, we've unplugged the coil, and we've inserted the spark tester into it. We're getting ready to hook the ground up, and then we'll perform the spark test. All right, this time we've connected our spark plug tester. All right, as you can see, we got spark on the spark tester. All right, this time we've hooked up a trainer with an oscilloscope to show how the signal wire works to control the injectors. Now, here on the graph, the top line represents the saturation in the coil. The dip is the actual spark when the spark plug fires, and that's basically how the system works. Saturation, it saturates and holds the power until the points make contact, so that makes power, gets the signal to open and release the spark.